Welcome back. This module, as you can tell, is about interpolation and spatial statistics. So I've talked about 4 different methods for doing interpolation so far. There's trend, inverse distance weighted, spline, and natural neighbor. I've got one more to talk about. In order to do that, I had to get your mind ready to go with some statistics. So last time I talked about traditional descriptive statistics, the mode, the median, the mean, the variance, standard deviation, skewness, and kurtosis. The last method of interpolation I'm going to talk about is kriging, and the next 2 videos are going to be about kriging. So here's a question for you. Who is this? Of course, you likely don't know who that is, but you might think if we're going to talk about kriging, this person might be somebody named Craig, and sure enough, his name is Danny Craig. He's from South Africa. He died a couple years back. And Danny Craig was a giant of geostatistics, and he came up with this method of doing interpolation that's now known as kriging. And kriging, it turns out, if you have the right kind of data, can give you superior quality interpolation. It's really difficult to do well, and it's an advanced topic, so I'll just be covering the high points of it during the next 2 videos. Okay, so back to the same example. We have Utah, an elevation raster. If we're trying to approximate that, given only information about the elevation of airports in Utah, and we use kriging, this is what we might get. So you can see that it gives you a reasonable approximation of the surface of Utah. Not necessarily astoundingly better than the other methods we've already looked at, but it will give you better methods. And in addition, it'll give you something else which I'll tell you about in the next video. Okay, if we had more points available instead of just all of the elevations of airports in Utah, we had all of the elevations of all of the points that have names, all of the genus points for Utah. We could get an even better approximation using kriging, and you can see where this one is starting to get a pretty good approximation with just a very restricted level of information. The thing about kriging is you have to have data that meets the assumptions that are behind kriging. Kriging is going to use some statistical analyses to do the interpolation, and so some statistical assumptions have to be in place and met before kriging is going to work well. If they aren't met, you shouldn't use kriging. So I'm going to walk through the rest of these for the rest of this video. You need the data to be spatially continuous, spatially autocorrelated, stationary, normally distributed, no global trends, and no spatial clusters. So you can see there are a lot of assumptions that must be met before your kriging is really going to give you the best interpolated output. So what are these assumptions? Spatially continuous versus discrete means that every point has a value. So you can imagine a continuous phenomena, let's say temperature, elevation, pressure, things like that. Even if you don't measure at every point, the phenomena is spatially continuous, which means there's a value at every point, even if we don't have a point of measurement there. If it's discrete, use another method. Spatially autocorrelated, that goes back to Tobler's first law, and Tobler's first law basically says things that are closer to each other are more alike than things that are further apart. And so locations closer in distance are also closer in value. That would be what's called positive spatial autocorrelation. If the data aren't autocorrelated, use another method. Stationary. What does stationary mean? It means the relationship between 2 points and their values depends only on the distance between those points and not where they're at. So you can imagine a map that covers a large study area, and if points that were separated by 100 meters had very similar values in one part of your map, and they didn't have similar values if they were the same distance apart in another area of your map, that would be non-stationary. So your data needs to be stationary. It kind of needs to be consistent across the map. It's not stationary, use another method. Normally distributed, I talked about that in the last video. So what does that mean? That means the mean and the median are similar in value. The distribution follows that bell-shaped curve, right? And it has the right size tails, so it has the right size kurtosis, and it's not skewed. It's not leaning one way or another in terms of long tails sticking to the left, which would be negative skew, and to the right, which would be positive skew. Sometimes you can transform your data to make it normally distributed, and then you can interpolate based upon the transformed data and then you can transform it back to what it was originally. So there's sometimes ways you can get around something if it's not normally distributed, but if you can't transform it into normal data, then that's probably not good to use kriging. No global trends. That has to do with stationarity, right? If things are more alike, depending upon what part of the map you're at, there may be a trend in one direction or another. I showed you some trends in the interpolation method, which was the first one that I showed you. Remember, you could pick an order of trend and get a surface that fits your data. If you have trends in your data, then you don't want to use kriging. Sometimes you can detrend your data before you krig it, then do the interpolation, and then go back and reverse that detrending to get final interpolation values. So sometimes you can kind of get around that. No spatial clusters. That is involving how many points you have and how they're distributed. So let's say you collected a lot of data, but you collected most of your data close to the road because that was easy to do, and you didn't go out into the wilderness because it's hard to collect points there. You might have clusters of data along the road. In some places you might have very sparse data, in other places you might have very dense data. So spatial clustering is important. If you have clustering in your data, you can decluster your data, which is basically the equivalent of giving data that's clustered a lower weight. So you might have 100 points in one area versus 10 points in another area. You reflect the weight that you give each one of the points when you're doing interpolation to take into account that you got a lot of points in one area and not so many points in another area. So you can decluster your data and still do kriging. So the last three assumptions, you can kind of get around them if you use some fancy tricks, but if you can't get around them, you should use another method. Spatial autocorrelation. This is kind of the key behind kriging, and spatial autocorrelation depends upon how values are similar or dissimilar depending upon how far apart the points are. So you can imagine having 2 points that are separated by a certain distance, and each point has a value. So you can take the difference in the value between those 2 points, square that difference, and plot it along an axis that reflects how far apart the points are. And that's going to give you the semivariance. This will be the semivariance because it's divided by a half. So you take the value at one point and you subtract the value at another point. You square that difference. So negatives will square to positives and positives will square to positive. All these values will be positive. And you plot it based upon how far apart these 2 points are. And that's going to give you this thing, which is called the semivariogram. So kriging is going to use the information about how spatially autocorrelated the data are to statistically predict what type of weights should be applied to points depending upon how far apart they are. The way that it's going to do that is you're going to make a model, you're going to fit a curve of some sort to all of your point pairs, and you're going to use bins. So instead of using all of the points, you're just going to use some of the points. You're going to fit a model to that and statistically apply the interpolation. So this is going to be the semivariogram. It's going to be the key to doing that. So Tobler's law says everything's related to everything else, but near things are more related to each other. That's Tobler's first law. What kriging is saying is up to a point everything is related to everything else, but near things are more related to each other. So after some point, kriging is saying things aren't necessarily related. So if I've got a point that's 100 miles away from my point, it's probably, or very likely in many cases, not going to be related to my point. Its value isn't going to be related to my point. So what kriging will do is it will have you select what's called the range, and within the range, points that are separated by this distance or less, then kriging says things are related according to this curve. After you get past this point in the range, things are just randomly related. There's no specific relationship between points. The sill has to do with the relationship in values between those points. So when you do a kriging model, you're going to do a range and a sill, and you're going to have another thing called the nugget, which is how far up from the base the bottom of this curve is. You're going to tell that to kriging, give kriging a model form, and let the statistics take over for the interpolation. Okay, you can see that that is pretty complicated stuff. If you're going to do kriging, you got to really know about your data. You got to look at your data and see whether it satisfies the assumptions that are behind kriging, and then you've got to build what's called a model that you use to do the kriging that involves spatial autocorrelation. So next time I'll go through an example of some data for Utah, from one of the counties of Utah, and how you might look at it to see if it meets the assumptions that are required to do kriging, and then do the kriging itself and see how good a job it does at interpolating things. So that'll be the next video.